Hey, hi. So in this video, we're going to be learning about straight line graphs. So these pop up a lot in graph questions, and they're in this form, which we'll talk about later. But before we go to more of the more usual ways of figuring out how to plot a straight line graph, let's just talk about this table method, because this method here is one you can use to plot any equation that you're given. So whenever you get the equation for a function, you can use this method to plot it on a graph. And it basically the method is that you get these x values, they're normally given to you, and then all you have to do is substitute them into the equation to get a corresponding y value. And then you can plot the points and draw the graph. Okay, so all we need to do is think about it for each case. So for x equals -2, we just substitute -2 into this equation. And then so we get -7. For x equals 0, we get y equals 2 times 0 minus 3. So we get -3. For x equals 2, we get y equals 2 times 2 minus 3, which is 1. And for x equals 4, get y equals 2 times 4 minus 3 equal to 5. So we can put all of these coordinates into the corresponding y values, like so. So now we have our coordinates, so we can plot them. So let's start. So first off, let's just put in the values in the x-axis that we want to plot. And now let's just put our corresponding y values. Obviously, it's not gonna be completely to scale here. Not -1, sorry, 1. Move this here. We've got 1, and then we got 5, like that. So if you'd usually use graph paper for this, so it wouldn't be it'd be more clear, but yeah. So we have -2 -7, so that'll be this point. We have 0 -3, so that'll be this point. 2 1, that point, and 4 5 is that point. And you can see that we have a straight line going through the points, roughly. But obviously on graph paper, it will be more precise. So that's how you plot straight line graphs. But the thing is, you only actually need 2 points, bear in mind, because straight line graphs don't change gradient, we say, or we could say direction. They're just straight. You'll only need 2 points to actually know what the whole line looks like. And that's something we'll use later. Okay. Moving on. The main form we use for straight line graphs is this form. Y equals mx plus c. And you can see that it's actually similar to the equation we have here. Y equals mx here plus c, just that. And what this means is, first off, this is the gradient, and this is the y-intercept, which we'll talk about in a second. But something to bear in mind is in y equals mx plus c, in this form, what we've shown here is whatever x value we put in, no matter what x value we put in here, we're gonna, if we substitute it into this equation, So yeah, we can see that this is in the same form as this, so as y equals mx plus c. And what it shows us is that no matter what x we put in, for example, here we put in -2, 0, 2, and 4, the y we get out of this equation of y equals mx plus c will give us a point on the line. So every x here, every x value gives us a corresponding y value of the points on this line. And that's why this equation is so useful, because once you find out the gradient and the y-intercept, you can just put values of x and get values of y, or put values of y and get values of x. So it's really useful. So what we're going to do is we're going to show now that we know how this equation works, you're probably thinking, okay, you say it's powerful, but how do we get the gradient and the y-intercept? Because it's just a bunch of letters otherwise. Well, now I'm going to show you how to figure out these two values to get into the form we want. So first off, let's talk about the gradient. So what is the gradient of a graph? Well, the gradient actually refers to the graph's how steep the graph is. So a line with a gradient, with a high gradient, might be very steep like that. It's going up very sharply. So that's a high gradient. In fact, let's just do that. A line like this will have a lower gradient because it's less steep. It's going up by a lower amount, proportionally. And then this is a line with gradient 0 because it's not going up or down. It's just staying flat. And then you have negative gradients, or lines which are going downwards, and obviously more negative gradients, or like very negative gradients, go down more sharply. So this is I can say this is decreasing gradient. And here m would be 0, and here m would be below 0, here m would be above 0. Okay, nice. Well, there's actually a more formal way we can write this, rather than, oh, how steep it is. In fact, to calculate the gradient, you need to know the ratio between the change in y and the change in x, and I'll show you what this means. So if you have a graph like so, let's say the graph hits the y-axis at -1, and then has a point here, which is 2, 2. All right. Now, what we want to do is we want to find the gradient. So this can be example 2, find gradient. All right. So the formula to use for this is the gradient is the change in y over the change in x between 2 points. Or what we can do is, if we make this a coordinate, so this would be 0, -1, like that. What we can do is we can label the first coordinate as x1, y1, and the second coordinate as x2, y2. And then the change in y will just be this. So it will be this bit. In fact, let me do this in another color. It'll be this bit. So this is our change in y, or sometimes we write it as delta. You don't need to know that, but that symbol just means change in. And then we have the change in x as well. So what we want to do is we want to find this value here and then divide this value from it. So what we can do again is we've labeled these coordinates. So what we can do is we can say, well, this change in y here is just y2 minus y1. And this change in x is just x2 minus x1. So we can write that as y2 minus y1 over x2 minus x1, like that. And that is our formula for the gradient. So either you can use this if you have two coordinates, or you can use this if you have the lengths of these lines. That's how you find the gradient. So in our case, we have two coordinates. So let's use this second form. So what I'm going to do is I'm going to, that's too bright. Let's do that. Okay. So we have y2 equal to 2. So m equals 2 minus 1. So that's minus 1. Remember, the signs are important. So we have a double negative here because this is a negative, plus we have a negative here. So do bear that in mind. And then we have the change in x, which is 2 minus 0. And then two negatives make a plus. So we have 3 over 2. And that's our gradient. So that's how steep this line is. And it's basically, the reason this works is because we said the higher the gradient is, the steeper the line is. So the higher the gradient is, the more y is going to change for little x. So if the graph was really steep, you'd see huge increases in y, but little increases in x. So m would be big. But if y is smaller, you'll get a lower gradient. And if y is going downwards, you'll get a negative change in y. So you'll get a negative gradient. And also, one last thing to point out is that it doesn't really matter which order you use these coordinates. In fact, I'll show you. If I chose these two to be my x2 and y2, I'd get I get minus 1 minus 2 over 0 minus 2. And then that would give me minus 3 over minus 2. But remember, when you divide two negatives, you can cancel the negative out. So that'll give us 3 over 2. So it doesn't matter which way we use these coordinates. Okay. One last thing is we can actually find the y-intercept of this line as well. So let's do that. So the y-intercept is basically when it intercepts the y-axis. So when it crosses the y-axis. So it crosses the y-axis at 0, minus 1. So our y-intercept is just this y-coordinate here. And you can see that it crosses the y-axis at that point in y. So that's it. That's all the y-intercept is. So c is minus 1. So now, if we go back to our equation, we can see that example 2 plus 3 gives us y equals 3 over 2x minus 1, because our gradient is 3 over 2, you can see, and the y-intercept is minus 1. So that will be the equation you can use to draw your graphs. And then obviously now that we have it in that form, we can plot it using this method or just by getting any two coordinates and drawing the line. So now that we've learned how to find the equation from a line, let's do the opposite. Let's try and draw the line from the equation without using this method. We can use an easier method. So what we want to do is, let's say we have to draw 3y plus 9x equals 12. Like so. The first thing we want to do is we want to get into the form y equals mx plus c, because then we know the gradient and the y-intercept of the line. So let's do that first. First off, we want the y to be on the left-hand side. We want the c and the mx to be on the right-hand side. So we can see that this is our y, this is our mx, and this is our c. So what we can do is we can rearrange it. So we have, this is the y term, I should say. So we can rearrange it. So if we subtract minus 9x from both sides, or if I subtract 9x from both sides, sorry, I'll get minus 9x plus 12, like that. But remember, we only want one y here, not 3. So what we can do is we can just divide both sides by 3 to get 1y on the left and minus 3x plus 4 on the right. And I'm just going to point out that you might sometimes get decimals out of this. They might not always give you whole numbers. So, but don't be deterred. You do need to make it so there's just one y. And then finally, you just plot your graph again. But now we know our two values. We know that's the gradient and that's the y-intercept. So what we can do is, because we know it crosses at 4, we can put that as our y-intercept. So we already know one of the points. And then we also know the gradient. So we know that because we know that the gradient is the change in y over the change in x, and that's 3. Well, 3 is the same as saying 3 over 1. So what we're saying is that it changes in the y-axis by 3, or minus 3, sorry, for every time it changes in the x-axis by 1. So if we went forward by 1 in the x-axis, we go down by 3. So if we went forward by 1, we go down by 3. And then if we went forward by 1 again, we go down by another 3. And it'll keep going like that. And then we can just plot these points. Again, you'll have graph paper, so it'll be easier. And it'll be the same up there. And then we can just draw our line, like so. Yeah. Like that. Something like that. All right. There are also some special lines I want to talk about, or special properties. There are 4 of them. So first off, we have 2 special kind of lines, and they're horizontal and vertical lines. So we can get lines that go like that. So they're completely vertical. And we can also get lines that go like this. They're completely horizontal. So the thing is, you can't say, for example, that this has an infinite gradient, because it would be going up infinitely in y without moving in x. So there's an easier way of writing these ones, and that's whenever it crosses at x, we say that x equals the number. So let's say it crossed at 4. Well, the equation of this line would just be x equals 4. Because if you think about it, x does always equal 4 in this line. And then here, similarly, if it crossed at 3, we'd say y equals 3. And you can actually see this because we have a gradient of 0. So you have 0x plus a y-intercept of 3. So y will always be 3. So that's a bit more intuitive. But whenever you have horizontal or vertical lines, they just equal either x or y equals a number that they always are. So it's constantly a single constant. That makes sense. Now there are two more properties, and that's if you have two lines which have the same gradient, we say they're parallel lines. And you might know that they never touch each other. Parallel lines, same gradient. And we denote them using these arrows to show that they're parallel. Now, for perpendicular lines, they cross at right angles. So perpendicular lines have gradients which are negative reciprocals of each other. And basically what this means is a negative is just a change of sign, and reciprocals are when you put something, if you put 1 over a number. So what I'll show is, for example, if m is if we say that the gradient of this line, or the m1, let's say, is 5, and the gradient of, oh, well, it wouldn't be 5, would it? Be, let's say the gradient of this is m1, and the gradient of this is m2. I think that will be easier. Let's say this is m1, this is m2. So the way that m1 would be related to m2 would be with this formula. So what you do is you put the other gradient in a fraction, so 1 over the other gradient, and then you take the negative. So for example, if m1 is 5, which doesn't really make sense with that graph, so I'm going to put something like 2. Then m2 would be, well, you just put that 1 over, or let's say a half, sorry, just makes more sense. So if it's a half, what you do is you put it 1 over, so you find the negative, and then you put minus 1 over a half, like that, to find m2. And 1 over 1 over 2 is the same as just saying 2. So you get negative 2. And obviously the other way around, you can also find m1 by putting 1 over minus 2, which will give you which will give you a half back. Minus 1 over, yeah. So I'll give you a half. But yeah. Okay, so now to finish off, we're told, or I told you that you can find the equation, and we did. We found the equation of this line here when we had 2 coordinates, and you're expected to know that. So when you get 2 coordinates, you can find the gradient by looking at the change, and then find the y-intercept by looking at where it crosses. But what another way you can find the equation of the line is when you're not given 2 points, and that's when you're only given 1 point. All right, so in this example, we have that a line L crosses at, or goes through the point -3, -2. And then we have a parallel line to L has a gradient of a half. So we need to find the equation of L. All right, so before we had 2 coordinates, and that's what we use to find the equation, but now we only have 1 coordinate. But the thing is, because this is a parallel line, we know that if the gradient of a parallel line to L has a gradient of a half, remember, parallel lines have the same gradient. So we know that the gradient of L, grad of L, is also equal to a half. So now we have 1 coordinate and a gradient. And that's the thing. You're going to be asked to find the equation of a straight line graph only if you're given 2 coordinates or 1 coordinate and the gradient. So now we can get our y equals mx plus c. And what we can do is we can substitute in our half. But now we've come to another issue. We don't have a graph this time to find c. So we can't just put in a value of c. We need to find c algebraically. And the way we do that is we use the coordinate that we've been given to put that into the equation. So we get, well, remember, when x is -3, at the beginning, we learned that whatever value of x you put in, you get the corresponding value of y on the line. So if x is -3, then y must be -2. So we just put that coordinate in to this equation. And then we just do some rearranging. So so a half times -3 is -3 over 2. And we can just move that over. So we add 3 over 2, and that will give us c equals -1/2. So the answer we get is y equals 1/2 x -1/2, like that. So that's how you'd figure that out. Okay, so I'll have a go at some of these exercises, and this will go through each of the points that I've mentioned in this video.